Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B1241, also indicated by the error code 59, signifies a malfunction in the blower motor circuit of the Honda Accord, produced between 2017 and 2023. This issue can affect the proper functioning of the vehicle's climate control system, specifically in terms of air distribution within the cabin. The blower motor is a crucial component located within the dashboard area of the vehicle, typically near the HVAC, heating, ventilation, and air conditioning assembly. By moving air through the cabin vents, it regulates the vehicle's interior temperature, enhancing comfort during drives. It operates based on signals received from the climate control unit, which interprets user input and commands the blower motor to act accordingly. A fault in this circuit could lead to a range of issues, thereby triggering DTC B1241, necessitating a systematic approach to troubleshooting to ensure correct identification of the root cause. This DTC B1241 indicates a specific problem in the blower motor circuit. The primary affected component here is the blower motor, which is responsible for drawing air through the HVAC system and delivering it into the cabin. The blower motor operates based on power supplied through a circuit that includes various fuses, wires, and connectors. Typically situated behind the dashboard, the blower motor draws power from the battery and receives commands from the climate control unit. This circuit is also connected to relays and power transistors, which serve to regulate the voltage and power delivered to the motor. Any disruption or fault within this circuit, such as a blown fuse, connection failure, or damaged wiring, can trigger the DTC B1241. It's crucial to thoroughly inspect all components within this circuit during the troubleshooting process to ensure effective repair. Several possible causes can lead to the emergence of DTC B1241. A common culprit is a blown fuse, specifically fuse A35, which protects the blower motor circuit from electrical overloads. If this fuse is faulty, the circuit cannot supply the necessary power, leading to the motor's failure. Another possible cause is a faulty blower motor itself, which may have internal problems preventing it from operating correctly. Furthermore, wiring issues such as loose connections, damaged wires, or poor grounds could interrupt the circuit's integrity, causing failure in the blower motor's performance. Diagnosing these issues requires careful inspection of electrical components and connections in the blower motor circuit to determine the actual source of the problem. The presence of DTC B1241 can result in several noticeable symptoms affecting the vehicle's usability. One of the primary symptoms is a complete lack of airflow from the climate control system, which indicates that the blower motor is not operating. This can lead to discomfort, especially in extreme weather conditions where regulation of cabin temperature is essential. Inconsistent climate control may also manifest, where the blower operates intermittently or at different speeds than commanded, suggesting potential faults in the motor or control unit. Additionally, drivers might notice a failure in the heating, ventilation, and air conditioning (HVAC) functionality, rendering it ineffective in maintaining a comfortable environment inside the vehicle. Identifying these symptoms can lead to early diagnosis and repair, helping restore the blower motor's function. The first step in troubleshooting DTC B1241 involves verifying the problem using the Honda Diagnostic System, HDS. Initially, you need to clear the DTC codes using the HDS, which resets the vehicle's computer and removes previous error codes. Next, turn the vehicle to the off, lock mode, and then switch it back to the on mode. This cyclic operation is vital as it ensures the vehicle's systems are initialized correctly. Following this, execute the self-diagnostic function using the HDS or the climate control unit to scan for current DTCs that may indicate ongoing issues. If DTC B1241 reappears during this check, the failure is confirmed, allowing you to proceed to step 2 in the troubleshooting process. In the second step, checking fuse A35 is essential to ascertain its condition. Begin by ensuring that the vehicle is in the off lock mode before you attempt to inspect the fuse. The fuse A35 specifically protects the blower motor circuit from damage due to electrical overloads. After locating the fuse, check if it is intact and functioning properly. If the fuse is okay, you can proceed to the next step. However, if it is blown, replace it and retest the circuit. It's crucial to address any recurrence of blown fuses, as this indicates a possible short or other serious electrical issues that need immediate attention in the corresponding fuse circuit. The third troubleshooting step involves checking the power circuit to the blower motor. Slightly changing gears, disconnect the blower motor's 2P connector to isolate it from the circuit. After disconnection, turn the vehicle to the on mode, which powers up the electrical systems, including the relevant circuits. You will then measure the voltage between the designated test points, specifically between the number 2 terminal of the blower motor connector and the body ground. If you find battery voltage at these points, it indicates that the circuit supplying power is functioning properly, allowing you to move forward to step 4. However, if there is no voltage detected, it warrants further investigation, prompting you to go to step 12 to check for possible disruptions in the circuit. In the fourth step, you will verify the operation of the blower motor itself. Begin by turning the vehicle to the off lock mode, and then reconnect the previously disconnected blower motor 2P connector. This allows the blower motor to receive power again. For testing, you will need to connect terminals A and B using a jumper wire, specifically connecting the number 1 terminal of the blower motor connector to the body ground. Once everything is securely connected, switch the vehicle to the on mode and observe whether the blower motor operates at high speed. If the blower does run correctly, it confirms that the blower motor is functional, leading you to proceed to step 5. Conversely, a lack of operation indicates that the blower motor itself is defective, necessitating its replacement. The fifth step focuses on checking the ground line for continuity, critical for the operation of the blower motor. Start by turning the vehicle back to the off lock mode. Disconnect the jumper wire used in the previous step before proceeding. Next, you will disconnect the 4P connector from the power transistor, as this connection impacts the continuity check. You need to measure continuity between the third terminal of the power transistor connector and the body ground. Achieving continuity signals that the ground wire is functioning correctly, allowing advancement to step 6. On the other hand, if continuity is absent, delve deeper to search for an open circuit in the ground wire. It is also essential to check for proper grounding at connection point G303, ensuring a comprehensive diagnosis and repair. The sixth troubleshooting step tests the integrity of the blower M line, determining if the circuit allows for proper functionality. To begin, use a jumper wire to connect terminal 3 and terminal 4 of the power transistor's 4P connector directly. This reconnects the circuit and sets up for an operational test. Once configured, turn the vehicle to the on mode and monitor whether the blower motor operates at high speed. Positive results indicate that the blower M wire is intact and functioning correctly, permitting progression to step 7. Conversely, if the blower motor does not run at expected capacity, it signifies an open issue in the blower M line, necessitating further examination and repair of this specific wire. In this 7th step, the focus shifts to the blower V line, which is critical for smooth electric functioning of the blower motor. Begin by ensuring the vehicle is in the off, lock mode. Disconnect the jumper wire used previously. Then also disconnect the climate control unit connector B with 24 pins. This action allows for exclusive access to check continuity effectively. Using a multimeter, measure continuity across the 12th pin of the climate control connector and the body ground. If you observe continuity, proceed to analyze the blower V wire for any issues. However, if continuity is detected in this step, it points towards a potential short circuit, requiring prompt attention and repair to resolve any grounding faults in the blower V line. The 8th troubleshooting step is crucial for assessing the state of the blower G wire, essential for proper motor function. Start by evaluating continuity between the designated test points, ensuring the vehicle remains in the off lock mode. This entails measuring between the 11th pin of the climate control connector B and the body ground, after making sure both the power transistor connector and climate control connector are disconnected. A successful continuity test shows that this wire is working properly, allowing you to advance to step 9. In the event of no continuity, this indicates a potential short condition in the blower G wire, requiring appropriate repairs to restore functional connectivity throughout the circuit. In the 9th troubleshooting step, focus shifts to testing the continuity of the blower V wire to ensure circuit integrity. Confirm the vehicle is in the off lock mode before beginning, and ensure that both the climate control connector B and the power transistor connector remain disconnected. You will need to check the continuity between the 12th pin of the climate control connector and terminal 2 of the power transistor connector. If continuity is observed, this indicates that the blower V wire remains intact and operational, allowing progression to step 10. However, if there is no continuity detected, an opening in this wire needs immediate attention for repair to restore proper functionality within the blower motor circuit. The 10th step involves another critical check for continuity, but this time focusing on the blower G wire. As with previous steps, ensure the vehicle is still in the off lock mode, maintaining the disconnection of both the climate control connector B and the power transistor connector. Measure the continuity between the 11th pin of the climate control connector and the first terminal of the power transistor connector. Detecting continuity verifies that this wire is functioning correctly and allows you to advance to step 11. Should there be a lack of continuity, there could be an issue affecting connectivity, necessitating repairs to rectify the blower G wire, ensuring smooth electrical flow in the circuit. In the 11th step, you will be testing the power transistor, which plays a vital role in the blower motor circuit. This component controls the voltage and current supplied to the blower motor based on input signals from the climate control unit. If the power transistor is found to be functioning correctly, it allows you to move ahead with replacing the climate control unit, as it could be the faulty element affecting overall system performance. On the other hand, if the power transistor fails to meet quality standards, you must replace it. Importantly, after dealing with the power transistor, always verify the blower motor for any signs of damage and replacement requirements to prevent future malfunctions in the wiring system. The 12th troubleshooting step is centered around the blower motor relay, which is another critical component in the circuit. Begin this procedure by switching the vehicle into the off lock mode, which is essential for safety while working with electrical components. Locate the blower motor relay in the underhood fuse relay box and remove it carefully for testing. Once removed, check its functionality using a multimeter or equivalent testing device. If the relay is functioning properly, you can proceed to step 13. However, if it's faulty, then it's necessary to replace the blower motor relay to restore proper function to the blower circuit. The 13th step involves checking the +B HTR-NTR line to ensure that it allows adequate power supply to the blower motor. After ensuring the vehicle is in the off-lock mode, you will measure the voltage at the first socket terminal of the blower motor relay while checking against a body ground. This test establishes whether battery voltage is present in this line. A positive voltage reading indicates that the wire is functioning correctly, which allows you to move forward. Conversely, if there's no voltage detected, this indicates an issue in the wiring, necessitating prompt repairs to the +B HTR-MTR wire to facilitate proper operation in the blower motor circuit. For the 14th troubleshooting step, you will be assessing the IG2 AC line, as it plays a role in providing power to various components, including the climate settings and operation of the blower motor. Start the procedure by ensuring the vehicle is in the on mode to facilitate power flow necessary for testing. Once activated, measure the voltage between the third socket terminal of the blower motor relay and the body ground. A successful detection of battery voltage here signals that the IG2 AC wire is operating as it should. However, if you fail to register voltage, it points toward an issue within the line that will necessitate repair or replacement to maintain operational integrity in the HVAC system. The final troubleshooting step involves checking for continuity in the ground line as it relates to the blower motor circuit. You need to revert the vehicle to the off-lock position before carrying on. Simply check for continuity between the designated terminal of the blower motor relay and body ground. Successfully achieving continuity is indicative that the ground line is in good shape, allowing for further actions. If there is no continuity, then further inspection of the ground line is warranted to look for any possible opening in the wire. Additionally, ensuring proper grounding at G301 becomes vital to ensuring ongoing performance and reliability in the blower motor system. After all necessary repairs and adjustments have been completed, it's critical to conduct a final verification of the repair process. Commence by checking the functionality of the blower motor, ensuring that it operates correctly at various speeds as intended. Once confirmed, use the HDS to scan for any lingering DTCs, ensuring that DTC B1241 no longer appears. This represents an essential step in validating the repairs. Following a clean slate in terms of error codes, reconnect any disconnected components, such as wires and connectors, while ensuring that everything is secure and in the correct position. This thorough final check ensures that your repair work is fully successful and that the blower motor circuit is operating as it should. Preventive maintenance is an essential aspect of ensuring consistent and reliable operation of the blower motor circuit, especially in vehicles like the Honda Accord. It entails regularly inspecting all wiring and connections associated with the blower motor to prevent issues from arising due to wear or damage. Additionally, routinely checking the fuses, particularly the A35 fuse that protects the blower motor circuit, minimizes the risk of unexpected failures during operation. Keeping the blower motor free from debris and ensuring that it operates efficiently also contributes to extended longevity. By implementing these preventive measures, vehicle owners can avoid larger, costly repairs associated with the HVAC system in the future. In summary, DTC B1241 indicates a critical malfunction within the blower motor circuit that can significantly impair the performance of your Honda Accord's climate control system. It is crucial to systematically approach troubleshooting, starting with verifying the problem using the Honda Diagnostics system, followed by a series of checks that explore each component's functionality. Recognizing symptoms early on prompts timely interventions, helping to maintain comfort and safety while driving. Additionally, embracing preventive maintenance practices can enhance longevity and reliability of the HVAC system, preemptively addressing concerns before they escalate into major repairs. Overall, adhering to these troubleshooting and maintenance guidelines ensures that the blower motor circuit operates smoothly, providing optimal cabin comfort. Please like and subscribe to the channel. See you next time.